Alright, let's look at the homework 3.9, problem number 5. Alright, so this is a water trough problem. Alright, so I already drew the picture and I put in all the measurements there. Alright, so you have the water. And what we want to do is we want to express the volume in terms of maybe a height of the water, or a depth of the water, maybe I should say. So here, if the depth of the water here is, let's say, let's call it H. Alright, then how would you express the volume of the water? Alright, so what we're going to do is I'm going to look at this isosceles trapezoid, so it looks like this. Alright, then I'm going to draw a straight line here, vertical line here. And then you look at the right angle, right? So here's the water, right? So that's the water there, right? Then this is H right here, right? Then let's see, if you want to find, let's see, we have, maybe we should look at this little triangle here. Right triangle there, and you can see that this is a big right triangle and this is a similar right triangle, so we can do the ratio, right? So the height depth is 0.6, right? So here we have 0.6, and here, so let's see, so this is 0.8, you take away 0.2 and put the 1/2 of that, so it's a 0.3 here, right? And you can think of the you can visualize the other side. You have the same thing, and you have so this is going to be 0.3, and that's going to be, of course, 0.2, same as the bottom. All right, so you can see that the ratio of this side to that side is 2 to 1, right? So the ratio of H to that is going to be 2 to 1. So we know that this is going to be H over 2, right? Just doing the ratio, right? So if you want to find the area of this trapezoid, or maybe I should say volume of this water, we can do this. So volume of the water, right? So this is a trapezoid, so you have a 1/2 times the bottom, which is 0.2, plus the top is going to be 0.2 plus 1/2 H and 1/2 H, so 0.2 plus H, so 0.2 plus H, right? So this is the bottom plus the top, and times the height. Height is going to be H, right? So that will give you the area of this trapezoid. Then you have to multiply by 6 to get the volume. Alright, so we have that. Then what we're going to get is, let's see, so first thing is like 6 and 2 cancel out, so you end up with 3. So you're going to get, that's 3, right? And 0.2 plus 0.2 is 0.4 plus H, and times H, right? And if you want, we can just multiply out, so we can write it as a 3, then you have 0.4 H plus H squared. Alright, so we have that. So that's the volume. Then what else it's given? It says that the water is poured in at the rate of 0.1 cubic meter per minute. Right, so this is dV over dt. So this is the rate of change of the volume with respect to time. So that's given. Then we want to know, so what we want to find is, so dV over dt is given to be 0.1. Then we want to know how fast is the water levels rising, so we want to find dH over dt. Right? So what you can do is just go ahead and take the derivative. So if you take the derivative of the volume V with respect to t, we're going to get the dV over dt is equal to 3, just a number, right? And derivative of that would be 0.4, and derivative of that is 2h, but we have to multiply by dH over dt, right? So which is a good news because this is the guy we're looking for, right? So we can just divide through by 3 times 0.4 plus 2h. So you're going to get, I'm going to write the dH over dt on the left hand side. Then you have a 1 over 3 times 0.4 plus 2h. Then you have a dV over dt. Right? So this is going to be 1 over 3, 0.4 plus 2 times h. H is given, let's see, when water is 30 centimeter deep, so it's going to be at 0.3. So 0.3 meters times 2, so 0.6, which is kind of convenient. And dV over dt is given to be 0.1. Right? So we know that 0.4 plus 0.6 is 1, so it's 0.1 divided by 3. So 0.1 divided by 3, right? Or we can probably write it as 1 over 30. Alright, so let's type in 1 over 30. Alright, so let's check the answer. Alright, I came back and it looks like we got this one correctly. Alright, that's it. I hope that this was clear.